Hi folks, installment 82. Wow, MLOs, Math 2201. We're in Unit 8, Chapter 7, the very first section of Chapter 7 still. Section 6.1. Chapter 7 is not terribly long. Could be a real big topic, but we do it in a little more of an abbreviated form here. So we're going to look at the nature of roots. Sounds like something that has to do with trees, nature and roots. Okay, so we're going to look at some key terms, which are roots, zeros, and x-intercepts, and how they're kind of all the same, but not really. We're going to talk about possible numbers of x-intercepts, and then we're going to look at comparing the number of roots and the number of x-intercepts and see what all that stuff means when we put it together. Okay, so we're going to spend a little bit of time on this slide now talking about things. So we've talked about in the past the relationship or the correspondence between a quadratic equation and a quadratic function. Now, we're going to be a little more specific here. We're going to talk about the graph of the function itself, and the quadratic equation, and how they're all sort of linked up together. So, remember the quadratic equation has no y in it at all, okay? It's just got the 0 equals stuff. A quadratic function, we're going to make a distinction now and use the old-fashioned f of x notation that you should remember from grade 10 or from earlier parts of this course. Sometimes teachers will use that more often than they use y. It just depends on personal preference for a lot of it. And then when we talk about the graph of the function, we're going to talk about the relationship between the coordinates x and y coordinates on a graph. So we'll say y equals stuff. So we get a function, we have its graph, and we have a quadratic equation. And they all look pretty similar. The only difference is what's on the left side of the equation there. Everything on the right side is pretty much the same. Okay. Now, if we take the equation and we solve it, we get solutions to the equation, and we're going to learn how to do that algebraically in this unit. But if we were to do that, we get the solutions to the equation, which are what we call the roots. Okay? So the roots are the solutions to the equation. If we think about the values of x that would make f of x, the function, equal 0, we call those the zeros of the function. And they're exactly the same numbers as the roots of the equation, but we're just sort of talking about this stuff in a different context. We're talking about function values instead of just an equation on its own. So the roots of an equation correspond to the zeros of a function, and we're going to talk about the graph, which is going to be a parabola if we're talking about quadratics here. And points on the graph where the graph crosses over the x-axis are called the x-intercepts. And we know that the x-coordinate on the x-intercepts is the same number that we would have for the solutions of the equation, so they correspond to the zeros in the roots. Okay? So the y-coordinates, of course, are just 0 when you're on the x-axis. So the roots of the equation correspond to the zeros of the function and the x-intercepts on the graph. They're not all the same thing, but they're all the same numbers. They just have a different meaning depending on which context you're talking about them in. Okay? So our first example, if we look at the equation y equals x squared plus 3x plus 2. Now they're all equations because they all have equal signs, but this particular one is going to correspond to the quadratic, to the graph of the quadratic, because we're talking about y and x here. So we're going to say it has x-intercepts at -2, 0, and -1, 0. So if I were to draw a graph of this, those would be my x-intercepts, which means that the function f of x equals all that stuff is going to have zeros for the function at x equals -2 and x equals -1. So those values of x would make f of x equal 0. If I plug those x's into here, f of x would turn out to be equal to 0. Okay, put it in both places for x. And in the last case, if I think about the equation, 0 equals x squared plus 3x plus 2, it has roots of -2 and -1. So if I solve for x in the equation, I get -2 and -1. Okay, now that sounds like a whole lot of double speak or double talk to say the same thing a bunch of different ways. And it kind of is, but it's important stuff to make distinctions about. And we're going to see why in a sec. Okay, these are a bunch of graphs of parabolas. And each parabola, of course, comes from a quadratic function. We're going to talk about the possibilities of the number of x-intercepts that a parabola can have. So in this first sort of category we have over here, both of these parabolas have two x-intercepts because both of those parabolas are going to touch the x-axis in two places. Okay, so that's one possibility. We could have two x-intercepts for a parabola. It's also possible for a parabola to have just one x-intercept. It's kind of a special case, but it happens a lot. And the only way it happens is if we get just touching at that one spot where it just kind of bounces off the x-axis like that. Okay? It's also possible for a parabola to have no x-intercepts. It doesn't touch the x-axis at all. And whether those things work out one way or the other, or whatever one of those three cases you fall into, it's all about the vertex and the direction of opening. So if your vertex is below the x-axis, but the parabola opens up, you're going to get two x-intercepts. If your vertex is above the x-axis, but the parabola opens down, you're going to get two x-intercepts. If the vertex is right on the x-axis, it doesn't matter which way it opens. You're only going to get one x-intercept. If your vertex is above the x-axis and you open up, you won't get any. And if it's below the x-axis and you open down, you won't get any x-intercepts. Now, if we have two x-intercepts for one of these things, think about the graph. It means we're going to have two different numbers for our x-intercepts. So we're going to have two different roots for the equation. So they're going to be different numbers. We say we have two unique real roots. If we just have one x-intercept, we'd solve the equation. We'd still get two answers, but they'd be the same number. So we say we have two equal real roots. And if we don't touch the x-axis at all, we say there are no real roots. There are still roots, but they're imaginary. That's not a joke. It's a funny thing, but it's not a joke. Okay? So there's a subtle distinction between all these things. Roots for equations, zeros for functions, x-intercepts for the graph. And we had those special three cases to get the number of x-intercepts. If the vertex is above and we open up, or it's below and we open down, we're not going to get any x-intercepts. If it's on the x-axis, we get one. If it's above and we open down, we get two. If it's below and we open up, we're going to get two. Okay? Understanding is the key for this session.